Hey HBC, I wanted to send you guys a video with a little bit extra instruction and some examples just in case you need a little bit more after class today to get ready for that unit circle quiz on Monday. So in class we talked about kind of the key numbers here that are going to be used for sine and cosine. You got 1/2 and √3/2, which we called small, and large, which you'll see for any of the 30 or 60 degree angles. And then √2/2, you'll see for all the 45 degree angles, or pi/4. Okay, and then 0 and 1 are the quadrantal angles, so, pi, 2 pi, pi/2, 3 pi/2, 0. Okay. And then towards the end, we talked about, well, what if we're doing the reciprocal functions? And I've got a little typo here. This should be cosecant. Secant and cosecant. Okay, those reciprocal functions there. When we take the reciprocal of 0, undefined, and then 2, √2, 2√3/3, and 1. So we can use the same idea of if we've got the reciprocal of a small side, it's 2. Okay. And then finally, for tangent and cotangent, we didn't really get to talk about these, but I wanted to kind of show you where they come from. So if we're looking for, let's say, tangent and cotangent, it's always x over y for cotangent or y over x for tangent. So what we end up with is it's the same 5 numbers for each of those. It just depends on whether you're doing y on top or x on top. Okay. But when we have one of our, let's say, 30 degree angles, so if here's our unit circle, here's our pi/6 angle, you'll notice if we're going to do tangent, I'm going to do tangent for all these. So tangent would be the small side over the large side. Well, if we're going to do a small number divided by a large number, we're going to get a smaller answer. So if we compare this and this, okay, √3/3 and √3, we know √3/3 is smaller. Would you rather √3 million or √3 divided by $3 million? We know this is smaller. So when we do small over large, that's going to give us the small answer. So we could say tangent of pi/6 is √3/3. However, if I did cotangent of pi/6, now I'm doing large over small. Well, large over small is going to give me a bigger answer. That's √3. So we get √3. Okay. Let's move up here for a second. So then, oops, somehow that got lost in there. All right. With tangent, now if it's a 45 degree angle, tangent or cotangent, we know that we've got a medium on both sides. Medium, medium. Well, if you take a number and divide it by itself, because those are both the same lengths, you're going to get some version of 1. Might be positive, might be negative. It's positive, okay, in the first and third quadrants because the signs are the same for the medium sides. But in the second and fourth quadrant, the signs are opposite, so that's where we get negative ones. All right, and then lastly, the quadrantal angles. You just got to look out for 0 versus undefined. If your denominator is 0, then you're getting undefined. Okay? So let's do a few examples. Sine of 4 pi/3. So when I get this problem, what I want to do is I want to make a quick sketch of where that is. 4 pi/3, I know it's a pi/3 angle. It's bigger than 1 pi, so it's got to be in the third quadrant. So I'm looking at this third quadrant. I have those 3 angles on my circle. It's going to be the one closer to the y-axis. Okay, so since it's closer to the y-axis, I know I have a negative small and I've got a large. Okay, so sine, that's my y value. Sine, I want y. So I'm looking, oops, and it's a negative large. So I'm going to say that that's negative √3/2. Because I know this is one of my 30, 60, 90 triangles, and the large side is √3/2. But it's down below the x-axis, so it's negative. Okay, let's try another. Tangent of 11 pi/6. Okay, we got to think about tangent here. So I'm going to draw my axis. That wasn't very good. Draw my axis and my circle. Okay, 11 pi over 6 is in the fourth quadrant. So really I only want my quarter circle there. All right, 11 pi over 6. That's going to be the guy closer to the x-axis. So here we go. There's third angle. So I know I've got my negative small and I've got my large. So 30, 60, 90 again. If I'm looking at tangent now, okay, what I'm going to see here is that's y over x. So small over large. That gives me a small value. Well, my small value of tangent was root 3 over 3. But since I'm in the fourth quadrant, I've got a negative y value, it's going to turn into a negative root 3 over 3. Okay, let's just make one up real quick right here just to show the difference here. If it was tangent of, that's going to be 5 pi over 3. If it was tangent of 5 pi over 3, we're still down in that fourth quadrant, but now we are the angle closer to the y-axis. So my x is small, my y is negative large. Now for tangent, y over x, it's negative large over small. That's going to give me the larger tangent value is negative root 3. And it's negative again because of that negative y value. What about for cotangent? Well, cotangent, now we just need to think x over y. All right, so we have 7 pi over 6. Draw my axes. 7 pi over 6 is a little bigger than pi. That must be this guy there. Okay, always draw your triangle back up to the x-axis. Okay, so there we go. I have a negative large, and I have a negative small. Cotangent, I'm looking at x over y. So now it's negative large over negative small. So I need the large value. That's root 3. The negative and negative are going to cancel, so we get a positive root 3 is our answer. Okay, let's try a few more here. Secant. All right, so secant. Right away, what you got to think is, okay, this is the reciprocal of cosine. Okay, so it's 1 over cosine. Secant is 1 over cosine. So I'm thinking 1 over cosine here. Draw my axes. Negative 5 pi over 4. Oh, it's a negative angle. That means I'm going to go backwards. 5 pi over 4. That gets me here in the second quadrant. And it's pi over 4, so it's that middle angle. Medium, negative, and medium. All right, and it's the reciprocal of the x value, 1 over x, 1 over cosine. So I know my medium cosine value normally is root 2 over 2. Okay, it's going to have a negative answer here because we're a negative. But the reciprocal of root 2 over 2 is just root 2. Cosecant, pi over 3. Right? Thinking reciprocal of sine now. 1 over sine. Not sun. Sine. 1 over sine. So make my graph. Pi over 3 is first quadrant. Finally, a first quadrant one. Pi over 3 is up near the y-axis. Okay. You want to be as comfortable with where these angles are as possible. That's going to be a small side, and that's going to be a large side. They're both positive. And if I want 1 over sine, so I'm thinking 1 over large. Okay, 1 over large. Well, 1 over large, that's the reciprocal of root 3 over 2. Reciprocal of root 3 over 2 is going to be 2 root 3 over 3. And we're positive because we're in the first quadrant. 2 root 3 over 3. And I've got one more example. Tangent 3 pi over 2. Remember, go back and pause or rewind if you need to, if I went too fast on anything. So tangent 3 pi over 2. Okay, it's tangent. So I'm thinking y over x. If that helps, write it down. Y over x. 3 pi over 2. When it's a quadrantal angle, I like to just mark it with an x rather, because you can't really draw a triangle there. There's no triangle. Okay, so 3 pi over 2 is down there. between quadrants 3 and 4. It's tangent, so my y value here, sometimes it just helps to think of the point. This looks like the point 0, -1. So my y value is going to be -1 over my x value of 0. That's undefined. Whoa, what happened there? Undefined. That's better. All right, so hopefully this helped a little. You can find a ton of stuff on Unit Circle online, Khan Academy, YouTube. I'm sent that link with some that practice website, which is pretty good. And I like how it's got all the numbers that we talked about as the ones to be comfortable with. Okay, so let me know if you have any questions. Thanks. Bye.